So Mark Mills, what do you do for a living?
I'm a senior fellow at the Manhattan Institute, where I think about and write about tech policy and energy policy, and I'm also a partner in a tech venture fund where we invest in software companies for the oil and gas business.
How did you get there?
How did I get which?
Where you are right now, how did you get to
I should also add that I'm a faculty fellow at Northwestern University's engineering school. The dean is a good friend. I didn't go to that school, but I know a lot of professors there. It's a spectacular institution. I learn a lot hanging out with those guys. The Manhattan Institute, it evolved because I've spent my life writing. I began writing when I was in high school. I've run some writing contests as a young writer in fiction and nonfiction. I've just always liked to write. So I have a pathological compulsion to write stuff. But the Manhattan Institute evolved because I write. So I knew them, they knew me, and they invited me to join as a scholar some years ago. The venture work, I write about tech as well. No, I was a practicing scientist, an engineer early in my career. I have patents. I used to do useful work, build things, vet things in semiconductors and missile guidance and fiber optics, communication systems. So my early career was in building stuff. Then I went into nuclear weapons and strategic defense policy, the Reagan White House Science Office. That led to sort of consulting and then investing again. One thing led to another. I wrote a tech investment newsletter for a while. It was very successful. Migrated from that into doing some technology venture. Long explanation because I was no simple vector like going to business school and getting a job in a venture fund. I took my degree in physics and learned business the hard way by failing serially to make things work.
Well, you've written a book called Work in the Age of Robots.
Yeah.
Are you invested in robots, first off?
So yes, but I define robots or robotics as both virtual robots, Siri and Google and Voice and Amazon's Alexa are essentially robots. They're artificial intelligence engines that respond and do things semi-autonomously. So we do invest in those kinds of robots, but they're in the oil and gas business. I'm not an investor in the hardware side of robots. You know, C3PO kind of 2D2 kind of stuff. Although I like them, I've studied them for years. So yes, I have feel like I have a dog in the race in that sense. I have been a long-time fan and scholar and investor in the domain of robots. Now they're getting interested because they're starting to become useful, and that's both exciting and for a lot of people frightening because they think, as most people know, I mean the general trope that's out there is that robots, both virtual and real, are about to take away most work from most people, and we're all going to be put out to pasture like farmers were in the 19th and 20th century.
Well, in your book, you say that currently there are about 2 million industrial robots
in the world,
in action in the U.S. Where are they?
Oh, in the world.
In the world.
Yeah.
In the world.
They're mostly in automobile plants, the largest users of robots. And of course, these robots are usually 1 or 2 arms only. I mean, they're not walking, talking C3POs. They're automated welding machines, automated handling machines. So the 2 industries that dominate mechanical robots so far is car manufacturing and some electronics manufacturing. But that comprises about 15% of the manufacturing universe. Most manufacturers don't have much automation yet. The reason is because most robots aren't flexible enough. They can do tasks that are highly repetitive, easy to find, and they're always
assembly line type.
Exactly. And increasingly, a lot of manufacturing is not like that. And increasingly, even mass production is becoming mass customization. This doesn't lend itself to this kind of highly repetitive tasks. So robots aren't so good at that yet. They're starting to get better at that. The most exciting robots are called cobots, which is a term created by a Northwestern University 2 professors, Peshkin and Colgate, which it sounds like what it is. It's a cooperating robot. It works with you. This allows you to do more, and the robot to do things it couldn't do on its own. Some of those already exist. In a sense, Alexa is a cobot. If you think about Alexa or Siri can do things, but it needs you too. So there's a collaboration. So that class of robots is the most interesting. The Da Vinci surgical robot, which is the most successful surgical robot ever invented, and it's used typically for prostate surgery and liver surgeries, these non-invasive sort of micro intrusions. It doesn't operate by itself. The surgeon has his hands in a manipulator, looks through a screen or goggles and sees what's going on up close, but the precision that's affected by the robot is an amplification of the human. So this doesn't replace them. And there's no clear path, by the way, to easily replace the human. It's a bit like the idea of artificial intelligence or robots replacing people is a bit like calling a car an artificial horse or an airplane an artificial bird. Obviously, both serve a similar function, but they powerfully amplify that function in ways that a horse doesn't by itself. Robots are the same thing. They're not going to replace people any more than we don't walk anymore. I mean, a lot of us walk a lot less, some of us walk more, but we wouldn't walk to China. We wouldn't sail to China. So the amplification factor that the car or the ship or airplane made is what robots in fact do overall. And that's the key to the difference of the dystopian view, robots replace everybody, versus they amplify society, add productivity, add wealth, and ultimately add jobs.
You also say in your book that, and you use the car analogy, you say it's basically 1890 when it comes to the development of robots.
So I tried to think about the stage we're really at. I mean, because you have to use it, you have to analogize it in some fashion, and I do break it into two kinds of robots: the virtual robot, Alexa and Siri aren't good enough yet. They still, as most people know, pretty clunky. There's some very funny YouTube videos making fun of. Saturday Night Live did one of the best ones on Alexa, I thought. If anybody hasn't seen it, you should Google it up, as they say. Very funny. So they're good, but not good enough. But they're pretty good. So in automotive terms, our current artificial intelligence that's in the cloud, the virtual stuff, are kind of like Model Ts. They're pretty good. They're commercial. They're viable. They're useful. But Model Ts were open to the air. They weren't enclosed. I mean, they were pretty uncomfortable. And in 1918, Scientific American published a forecast of the future of the car. And one of their forecasts is that they believed it would be fully enclosed and weatherproof. So obviously a Model T is not so great, but it started the car age. That's where we are with artificial intelligence. We're at the beginning. When it comes to C-3PO, the general purpose, what's known as an anthropomorphic robot or a general purpose robot, like a general purpose computer, we're essentially in the 1890s, where the very first cars that were invented by Diesel and by Mercedes-Benz and by several American firms, they were making very clunky cars. They were cars, and in our dollar terms, they cost $200,000 or $300,000. Not many people bought them. They sold like 500 in a year, and then a few years later, they sold a few thousand. Then you get to maybe a few years later, you get to 1 million of them, but it's not like hundreds of millions. So in the robot world, when it comes to the anthropomorphic general-purpose robots, it's kind of like 1899. We haven't got a Model T yet. You can't buy a Model T. You can't name a robot, except in science fiction, that could walk around and do anything, except controlled by a person in a laboratory. And those look really great on YouTube videos, but you can't buy one. They don't exist as a product yet. It's very difficult to make those things.
Where are these robots that we have today being manufactured?
Well, the United States, Germany, and Japan are the three leaders in robotics in general. I think in an artificial intelligence, the virtual robot, the robot in the cloud, I have to say we're the leader. We really dominate the world right now. So if you look at products like Siri and Google Voice, but also the similar products to help doctors do diagnoses, to help plan for trips. These things are typically U.S.-centric in Silicon Valley and other domains of the United States. The physical robots, C-3PO again, we're pretty good at it, but Germany and Japan are comparably good. In some respects better. Japan is a true leader. They've already begun to test a commercial healthcare robot, which will solve a problem that's very serious in healthcare. If people are injured or they're older, they have to be picked up and moved. People do that. It takes two people, which is a very unproductive way to use nursing talent, to pick up a person, typically sometimes more, to do it carefully. it's clearly far more productive if a robot that was compliant and had just one task that could help the nurse or the doctor pick you or me up and move you from journey to bed. Those are possible. They're starting to be commercialized now. It's a very narrow, specific purpose robot, not general purpose. But if you look at that, it doesn't replace nurses. It actually amplifies the efficacy of a nurse or a doctor. It helps you, it reduces healthcare costs because a nurse is doing other things which are more valuable than being, brute force.
2 million more robots coming online in the next decade or so.
Industrial robots.
Industrial robots.
But probably 20 million more service robots are coming online in the next few years, literally. But these so far do very specific and narrow services like the healthcare robot. They vacuum. The most popular robot sold by volume is like Roomba, the vacuum. The second most common robot sold at volume today is the robo lawnmower, which are becoming popular, mostly among men, unsurprisingly. And maybe you could be sexist, I guess, and say that the vacuum is popular among women, but in fact it's popular among men and women. And the third robot, which is really a robot, is our autonomous drones are now coming up as a significant class of robot, because if I deliver a package, and by this I don't mean Amazon in the city, that's not happening yet, but in rural areas and in Africa, there are now commercial deliveries of medicines by robots, but they fly. They're not walking there. They deliver the medicine to an outpost and fly back and get up new supplies. Far more effective than trying to have a person drive a truck. Much more effective than trying to have a robot walking, obviously. Those are powerful amplifiers. That market's growing faster than industrial robots because it's easier. If you think about the tasks I just described, they're far easier to engineer than in the industrial environments where I'm manufacturing big, complex, expensive things. But they're both starting to grow very rapidly. So if you're an investor, for example, this is an exciting place to be because, again, depending which class you're picking, you're buying Ford stock circa 1918. Pretty good time to buy Ford stock. Might not have been so good by 2008, but you had a 90-year run. That's not bad. Artificial intelligence, why it's so popular on Wall Street right now is because the analysts have correctly figured out that it's going to grow a lot. It's early days. It'll get a lot better. It'll get a lot less sort of annoying. Right now, I think most of us would agree the utility, the value of it's sort of, sometimes it works well, but often it's annoying. They don't work quite as well as we'd like yet. And that's because as powerful as computers are, they're still not good enough. They're still not fast enough. But that trajectory is still happening. We're still getting much more powerful computers year by year. So we're now clearly in sight of computing that's what I call useful. Useful computing means I don't have to figure out how to install stuff. I don't have to figure out how to ask it a question. It's natural. And the computer in the cloud can naturally talk to me and ask me, did you mean, is that what you meant? Like a person would. Is that scary? For some people, that's scary. I think for millennials, it's probably not. Maybe for my generation, a lot of people are nervous about it. But I think as they get effective and really help us in both healthcare and in the economy, I think people will adopt them. If they don't adopt them, there'll be no market. I think they get adopted.
So what is exactly the role of AI when it comes to robots?
Well, so artificial intelligence robots are basically the same thing, but in our mind we have this artificial dividing line. A washing machine is technically a robot. Right? It's an automatic washer.
But you're not including that in your count.
I don't. So the kind of robots I'm talking about are the kind where a welding or a machining task can be done autonomously. A small drone aircraft can take a package and deliver it to someplace and bring it back. Or where I could say to my phone or to Alexa, I'm thinking about flying to Las Vegas next week. What do the flights look like? I don't want to tell it a day because I want the robot, this is a robot in the cloud, be smart enough to remind me, well, Mark, you're supposed to have lunch on Saturday with so-and-so, you've got a trip planned with your children to this date, what date did you really want to fly? That kind of interaction doesn't exist yet. It can and should. That would be useful.
Mark Mills, you talk about a concept called ambient computing.
Yes.
Which is what?
So I don't take credit for creating the phrase. It goes back 50 years to a professor at MIT called Licklider, and he imagined that 50 years later, this is a pretty prescient guy, thinking a half century out, that computing would get cheap enough and effective enough that it would basically disappear into the background of our general life and be in the ambient environment. But that doesn't mean that everything becomes automatic. It just means that it's as easy to use as electricity. You don't think about electricity except when it doesn't work. You don't think about how it's delivered. You don't think about how to turn the light on. It's just easy. It's always available. It's always. So electrification is sort of an ambient feature of our modern society. Computing is not an ambient feature yet. It's still too awkward. We are moving towards ambient computing. Well, it'll be infused in most functions in a constructive, sort of useful way in the background.
Well, we do have quite a bit of ambient computing, don't we, today?
It's ambient.
Let's go online. Let's look at our phones. Let's check into a flight.
I would say it's readily available computing, but I still have to take something out of my pocket. I still have to go to a desk. I still have to have a very specific way of addressing it. I have to type something. I have to ask it in a precise way, because if you ask Siri in the wrong way, which of course is subject of a lot of YouTube fun, Siri gets very flummoxed. That's not useful. So the ambience is a feature of when it becomes just intuitive and natural. The computing adapts to me. I don't have to adapt to it.
Does Murphy's Law apply to computing, to robots?
Murphy always wins. Murphy's Law always applies. Yes, of course. So there will always be unintended consequences. Some really good. In fact, I would say history shows most of the unintended outcomes of new technologies are good. But there are unintended outcomes which are not so good, which we have to guard against both behaviorally, sometimes legally, laws and regulations, sometimes behaviorally as parents, how we deal with our children having access. I mean, when there were no cars, we didn't worry about kids being hurt and injured driving the car when they learned how to drive. So we have a culture that's unique in all of human history for the last century. You teach children how to drive a one-ton thing that can kill people. This is pretty scary. I mean, if you talk to somebody 300 years ago and said, we're going to let 16-year-olds drive around a thing that weighs a ton and can kill things, that required a cultural adaptation. We will go through a similar class of cultural adaptation to this new class of computing. But before that happens, the dystopians are wrong, but Murphy will still do some things which won't be so pleasant. And that's what will trigger both the regulatory, legal, and the cultural adaptation to how do we deal with these new tools.
Has the regulatory regime affected robots yet?
Well, it has, because the first thing that the FAA did was ban drones from being used without certification. And now they recertify them and give you some boundaries, how far you can't fly a drone out of eyesight without special license. So the regulators have reared their, I hate to use the word, but their ugly heads, so to speak. They have a role because you want to be sure things are done safely. So whenever new technologies come along, regulations make sense on two bases. One is you want to have common standards. That form of regulation actually accelerates new technologies when there's sort of common platforms. A simplistic example would be if every electrical appliance had a different kind of plug, it'd be hard to plug things in. Cell phones had very different plugs for a long time. Now there's only two standards. That kind of regulatory environment is sort of natural, and industries work with government or just themselves. The safety one, and the social ones are more challenging. And sometimes regulators are behind the curve. Sometimes they overreact. Sometimes they don't react at all. I would say that they overreacted on drones. Drones are very difficult to make effective for the kind of things people are thinking about. So regulating them prematurely, I just think they went too far. They've underreacted in self-driving cars because the technology is premature, way too dangerous. And we're learning that the hard way through some fatal accidents. I think you're going to see regulators tighten the noose. I hope they don't tighten it too much. We're a long way away from really effective self-driving cars, despite the hype. But to get there, they have to be safe. And that will require regulations. I work for a think tank that is a free market think tank. Doesn't mean we're against regulations. It means that you're against the wrong kind of regulations or over-regulating. And in those words, there's a lot of room for debate, but they mean something. Those words have salience.
Well, Mark Mills, the title of your book is Work in the Age of Robots. For every new robot that comes online, is that a job lost by a human being?
The short answer is no, but the similar short answer is yes, in this way. It's always been the case for all of humanity we have tried to invent machines to take labor out of tasks and services. It's what we've been doing forever. If we didn't, we'd all be living on 40 acres and a mule subsistence life. You've got to take labor out of things to lower their costs. What that means is that when you take labor out of something, that if you did only that task, and just that task, the person that did that labor went from 4 people to 2 people lost a job. But because economies are propelled, because there's more of those tasks done, you end up either with no decrease in labor or actually an increase. But doesn't mean that some people don't get displaced. That's the essence of the moral challenge of automation, of industrialization, has always been, especially since the dawn of the Industrial Revolution, not that you don't get more jobs from automation. You always get more. It's the tiny percentage who are displaced. They are literally unfairly displaced. We have a moral and not a legal, we have a moral and a social obligation to minimize that and do our best to help people who are displaced. That's always been the case. But it's a minority that are displaced. Most people benefit, the majority get a huge benefit. So those benefits, somehow we have to figure out how to help people who didn't benefit. There are ways to do that. In fact, the ways to do it, we now have the tools that are taking the jobs away are the tools that can help people. Social media, automation allow the kind of retraining and alignment of people with jobs and tasks you couldn't have done 10 years ago, 20 years ago. If you lose a job and you have skill A, an Uber-like, Airbnb-like platform can now make it much easier to find a job with company B. Very hard to do 10 years ago, much easier now. If I want to retrain somebody, retraining online, much easier, much cheaper now than it was 20 years ago. So for the first time in human history, the tools that are taking work away from some people will make it easier to retrain and get new work for those same people.
In your book, you take kind of an alternative view of the need for STEM jobs.
Yeah, well, it's alternative to the common notion that everybody has to be a coder. I mean, be simplistic, but there's a rush for kids and seniors to code. Got to learn to code. You can't code, you're not going to get a job. This is nutty. First of all, it's a statistical fact. There are more farmers than there are coders in America. And only 1% of the population actually farms. Of all jobs in America, only 8% are in STEM fields. 8%, not 18, not 80, 8%, not 10%. There aren't 10% of the jobs in America are in coding, in tech in general, science, technology, engineering, and math. We don't need everybody to be an engineer. We need people to understand it. I'm a physicist. I worked as an engineer as well. I think it's great to have brilliant physicists and great engineers and computer scientists. We don't need a lot of them. I mean, this whole revolution started with 8%, not even 8% of the workforce. So if you have a child that loves science, math, great. Encourage them. But don't discourage other kids thinking they can't get a job because they're not going to become an engineer or a coder. This is nutty. Not even tech firms have most of their employees with engineering degrees. Majority of employees in manufacturing firms are not on the manufacturing line, are not engineers. They do all the things that are the constellation of tasks around that. That doesn't mean, I think we're doing a lousy job of teaching science and engineering and math to non-scientists. I mean, we really have to step up on that. It's in terrible shape. But that's very different than saying, if you don't get a job as a scientist or engineer, you're not going to get a job. Future's not going to be like that. And in fact, it's going to be worse than that. I think the future of engineering is just like the future of farming. Engineers are so good at making things to do their tasks better that we'll need fewer and fewer engineers in the future, not more of them.
What's going to be the effect, in your view, of 5G on this robot revolution?
So 5G is insiders, the cognoscenti know what 5G means. I'm sure you do. Maybe your listeners don't know. It's the next generation of high-speed wireless connectivity to your cell phone.
Which should be online by the end of the year in certain locations.
It'll start rolling out. Most people haven't even got to 4G yet, which allows you to do. So if you've got 4G or LTE, you can get streaming video without jitter. 5G will let you to get high-def streaming video. It basically means you don't have to cable. It's like a fiber optic cable without wires. It's very important for robotics and for anything to do with automation. The most difficult thing with respect to a robot is that it needs more computing power than it can carry. So it's going to have a computing power around it, parked in buildings and underground, and it's got to be connected wirelessly to that to get that information, be updating. Basically, the brain will be in the cloud. It has to be very, very high speed to make that work. Only 5G makes that possible. So without 5G, There's no self-driving cars because you can't communicate properly. There's no there's no C3PO without 5G.
So at what point is the basic structure of the internet, in your view, is it going to have to change, or is it changing now?
It's going to have to change. It's changing now. So George Gilder and I share a common view of the state of the internet, where it's going. We're sort of in, I don't know what George's nomenclature would be. I say we're at Internet 3.0. Internet 1.0 was dial-up modems. Some of us remember them. Very slow. Internet 2.0 is what we have pre-today, which was pretty high speed, pretty nice. You could shop online. Internet 3.0 is the cloud, where we are today, which gives you Alexa and Siri voice. Internet 3.0 can't do the next generation of computing, and it can't do it for a variety of reasons, not least, and it's to George's point, and it's been mine for years, not least because of the security challenge that we have to solve. The security challenge, having secure communication, securing my information, my personal information, my banking information, my transactions, me controlling my data, all these things that people now care about, that requires a new architecture. The new architecture doesn't mean the old one's gone. It'd be kind of like saying, well, you know, trains couldn't get, it was very hard to take a train to the shopping mall, right? The car added a new infrastructure to the train infrastructure. We still have trains. We have as many train miles, ton miles today as 50 and 100 years ago of stuff moving around. Because we move a lot of stuff by train, but we move most people by car. So as the economy grows, the Internet 3.0 we have today will be just as big and bigger, but we're going to layer on an Internet 4.0, which will be different, be pushed to the edges, highly secure, naturally secure, so that all the kind of transactions. If you imagine I have profoundly intimate biological data about myself, which I will be able to have soon because I'll be able to eat a computer every day with my vitamin pill. Consumable computing is coming. I want that data for my doctor when I go to the hospital, but I don't want anybody else getting it. I don't want the government getting it. I don't want them to know when I'm getting sick. I want to know. How do I secure that? We don't know how. We can't do that today. The data volumes are too big to do with the current architecture. Security has an odd feature, and if I tell you this, it'll make sense. So cybersecurity seems like weightless and invisible compared to physical security. If I want to secure money, I got to put it in something big and heavy, like a safe. Right? I have to build locks and walls. I have to build physical infrastructure to get security. Gates and fences. This exact same thing has to happen in the cyberspace. And it involves hardware and power and overhead. And every time I add hardware, power, and overhead to communication systems, you don't see it, but it's real. It slows everything down. Just like any security does. No one wants the communications network to go slower, so it's going to have to get 10 times faster yet, your 5G question. 10 times easier yet, and then I can stick inside of that faster, easier system the burden, because now it's not as much of a burden, of security. Security costs energy, costs hardware, and costs time. Always. There's nothing magical about cyberspace. It doesn't have the same features as physical space, but you just can't see it. The reason you don't have it is because it's so darn hard. If it were easy, we would have done it. The reason that no coders in Silicon Valley that write new apps and games, they pay no attention to security. They don't, and the truth is they don't. And the reason they don't is because it's hard. It takes up so-called overhead, which costs money, slows stuff down. So things that are supposed to be fast become slow. Things that are supposed to be easy become difficult. I mean, anybody would tell you if you want to make your current system more secure, you do two-factor authentication. So you say, what does that mean? Well, it means all of us have already experienced it. I try to log into my account online, and the robot on the other side, which is a virtual robot, says to me, I'm going to text to you at this phone number, right? And you have to then put that number in, because that's a second channel that's outside of the computer channel. It's a cell phone channel. I can even do three-factor authentication when it's really important. I could say for all my banking transactions, and you could do this today, no amount of money can leave my account over, pick a number, $1,000, unless I'm phoned. You have to phone me. It's a third-factor authentication. Or you have to phone one of three people, my wife, me, or my dog. That can be done today. But think of how much it slows it down compared to Venmo, boom, pay, right? I want Venmo to have three-factor authentication in real time. Technically doable, difficult to do without faster networks, faster computing, push the edges. That's the architecture George is writing about in his new book. You know,
George Gilder.
Life after Google, which I'm promoting here for George. He's a great writer, a great thinker, but he's absolutely right. That's where we're going, and that will happen. And it's not because it has to happen; it's because it can happen, and everybody wants it. It's not like the government has to say, "I want more security. I want more security that's easy." That's what this does.
So, Mark Mills, this is a thin book.
It is. It's a 1/3 length book. The publisher has a series, this Encounter Books, that they do to push ideas out where their proposition is, if you write it in a third the length, people will read it, as opposed to a longer book. As all writers know, writing a shorter book is in some respects harder, because you're forced to compress your ideas, be spare, can't have a lot of sloppy extra information or extra words. To make your case, to make it briefly, is hard. So it was a good challenge. I liked the challenge. I hope I met the challenge of making the case that A, robots are coming, both virtual and real, and B, they're way overdue, and we need them because we're in a productivity deficit in America, and they're a great thing. We're at the cusp of one of the most important and biggest economic revolutions since the beginning of the industrial age. And it's not Industry 4.0, which is the nomenclature of the cognoscenti. It's more than that. The quote industrial revolution wasn't about industry, it was about transportation. It's about our culture, how our cities were built, how we personally got around, how we could entertain ourselves. All those features changed 150 years ago. We're changing them again for the first time in 1,000 years.
You include in here a survey saying that tech firms are thought to be ethical. Why do you
thought to be
ethical?
You know, it's interesting. The survey was surprising to me and encouraging. So not all businesses are ethical because businesses are run by people. I think most businesses, in fact, are ethical, especially in free societies. But people seem to think, according to these polls, that tech firms are particularly attuned to being ethical firms. I think it might be true. I mean, that's just, but this is just, I don't know. People I've met seem to want to do the right thing in the tech community. If they do, and this is sort of how I end my book, my charge to them is their moral responsibility is not to accelerate this revolution that's coming. They're going to do that anyway. Their moral and ethical responsibility is to deal with the Murphy's Law effects, the unintended consequences, the people who are displaced, who aren't the majority, they're the minority. I don't want the government doing that. I don't think that's a good role for government. I want those companies to be thinking about what damage they're causing. We should not be doing what Karl Marx wrote about at the beginning of the Industrial Revolution. We had the satanic mills, and we propelled the economy. No one denies the economies grew magnificently. But there was a lot of carnage along the way and damage to people's lives because the businesses weren't as attuned to the side effects, not just environmental side effects, some of social side effects. I think tech firms probably, if the polls are right, are more attuned to that. I think our whole era is more attuned to that, which means they need to step up, do something about it, which is not lip service. It's more than lip service. You have to think about what's happening, to my point that if your piece of artificial intelligence is displacing work. Word processors eliminated the typing pool. There's no typing pools. Spreadsheets eliminated the accountants in huge accounting offices. Those people got jobs, but there are people today whose jobs may be displaced by AI that won't get jobs. So create a social media platform to help those people get trained and get jobs. Make it something that's a feature, not a bug.
Now, your publisher is Encounter, and yes. Encounter usually publishes conservative books.
Yeah.
Is this a political issue that you're writing about?
It's a political issue because it involves policy and politics, so yes. I'd like to think it's not a political issue in the sense of left-right, conservative-liberal. There is some alignment on this. I think you do see some of the parties taking positions that you would call political on the technology, but so far it's kind of interesting. I'm not a Pollyanna. I don't think it will. I don't think we can avoid things becoming political. But so far, this issue is apolitical. The political part of it is what you do about it. So you have some people who say, if people's work is being displaced by automation, the more liberal side of the aisle would say, we should give them a universal basic income. We should give them an income. If we displace them with a robot, we should give them an income. I disagree with that profoundly. The conservative market side would say, well, if we displace somebody's job, we shouldn't give them an income. We should figure out how the market function to do something, make sure that person has help. We should still have a safety net, which is what unemployment insurance is. No one is saying you should get rid of those things, but I don't want to add new features. The reason I don't want to add new features is I know we don't need them. In 1961, President Jack Kennedy gave a speech to Congress, and he said the most important issue of our day is the loss of work in Detroit from automation. 1961. And he was right. Detroit was expanding its production at that time and laying people off simultaneously, because that's when the automation began on the assembly lines. He was so worried about it, he talked about a universal basic income in 1961. So did President Johnson after that. Thank goodness they didn't get to put it in place, but we did create things like unemployment insurance and those kinds of programs.
Mark Mills is the author. The book is called Work in the Age of Robots. Thank you.
Thank you.
Saturday at 10 a.m. Eastern on C-SPAN. Live coverage of the Democratic National